Okay, here are the 12.1 notes. This is page 6. So we have example 11. It's a common belief that most students gain weight during their freshman year in college. We've called that the freshman 15. Yeah, the cost of food right now, it may be the freshman 8, but whatever. So the freshman 15 is often used to describe the weight gain. Researchers studied this and found that the mean weight gain is 16.7 pounds. So here is our mean weight gain, 16.7. Weights were normally distributed with a standard deviation of 6.4. Okay. A, we want the probability that a randomly selected freshman gained more than 15 pounds. So here is my curve. There is my mean. Here, my standard deviation is 6.4. We're talking about a randomly selected freshman. So we're looking for the probability that some individual gained more than 15 pounds. So if our standard deviation is 6.4, one standard deviation away is 10.3, and we're looking for this somewhere in here, 15. More than 15 pounds, we're shading to the right. So normal distribution, norm.dist. The x that I am testing, the population mean, population standard deviation, and 1 for that cumulative function. Our probability that a randomly selected student gained more than 15 pounds. Just realized I did this backwards, so we're going to go back here and fix it. More than 15 pounds, and you're probably saying, wait, shouldn't that be 1 minus? I get 1 minus 0.3953. So I go through my answer key. I get the probability that a random student gained more than 15 pounds is 0.6047. Again, 4 places, rounded correctly to the 10,000th place. B, the probability that a random sample of 20 freshmen gained more than 15 pounds. So our population standard deviation is still population mean is still 16.7. Our sampling error, 6.4 divided by the square root of 20, I get 1.4311. Normal distribution, here's my mean, 16.7. One standard deviation now is minus 1.4 or 1.43, so 15.27. Notice the difference here. This time closer to the 1 standard deviation, so 15. So it should match. So now we've got the probability that the sample mean, x bar, is greater than 15. Again, 1 minus norm.dist 15, 16.7, exactly the same as above. My new standard deviation for that sample of size 20 and we get a probability of 0.8826. We are sampling 20 and taking that average. Okay? Makes sense that the average of all of those individuals would be closer to the mean. C, we've got the probability that a random sample of 30 freshmen gain more than 15 pounds. So our population mean is still 16.7. Our standard error here is changing. We've got a larger sample. We are dividing by a larger number. So I get a standard deviation that is smaller. I now have a standard deviation of what, 1.17, so 15.53 here. Notice now that my 15 lies to the left of that. Probability that our sample mean is greater than 15. Again, same x value, same mean, different standard deviation. Let's get this Excel command, and this one. This one I did separately. So probability our x bar is greater than 15, 0.9271.